Okay, today we're learning 2-4. 2-4 is all about describing proportional relationships and the constant of proportionality. So we're basically going to be making equations now that represent these relationships. So example 1, write an equation to represent a proportional relationship. A sponge is an example of a filter feeder. It takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. What is an equation that represents the proportional relationship between the time and the amount of water filtered? Okay, so we're looking for an equation here, and it lists time first. It lists time first, and then it lists the amount of water, okay? So now the equation we're going to be using for this entire lesson is y equals kx. K is your constant of proportionality. So K is the constant of proportionality. And when we find K, K is y over x. So we're going to make a table, hours, liters, and then liters over hours. Now we're listing hours first because it said time first in the problem. So hours is going to be our x, because x comes first. Liters is going to be y. And then liters over hours, that's y over x. This is going to be how we find our constant of proportionality. Okay, so if we look at the picture here, if we look at the picture, it says 8 liters in 10 hours and 12 liters in 15 hours. First, we need to figure out if these are equivalent ratios. So what we're going to do is, okay, so it's 10 hours for 8 liters, and then it's 15 hours for 12 liters. So we're going to start with that. Now, when you find the constant of proportionality, you always do y over x. So y over x. So 8 over 10. If you divided that out, you're going to get 0.8. 12 over 15. 12 divided by 15 is also 0.8. So that means we have equivalent ratios here. Our constant of proportionality, our K, is 0.8. So the equation is y equals 0.8x. That's our equation. Okay, try the next one on your own and pause the video and then play it and see if you got the right answer. Okay, Maria made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities. So grape juice, so we have apple juice is x, grape juice is y. For apple juice, that's 5. For grape juice, that's 8. We're going to do grape juice over apple juice since it's y over x always. So that's 8 over 5. And for this one, that's 16 over 10. If you divide these out, you're going to get 1.6, and you're going to get 1.6. So that's good because we have equivalent ratios. So the constant of proportionality is 1.6. And an equation that represents this proportional relationship is 1.6x. Okay, the convince me says, how does the equation change if the amount of grape juice is the independent variable, x, and the amount of apple juice is the dependent variable, y? So basically, we're flipping these right now. And so instead of doing 8 over 5, we would do 5 over 8, which equals 0.625. Same thing for the other one. So the equation would be 0.625, y equals 0.625x. So that's how it will be different. All right, example 2. 1 inch, to solve problems using an equation, 1 inch is 2.54 centimeters. How many centimeters long is an 18-inch ruler? Okay, so we're going to make an equation for this. Our constant of proportionality is 2.54 centimeters. So our equation, once again, y equals kx. X is going to represent inches. Y is going to represent centimeters. y equals 2.54x. Now, how many centimeters long is an 18-inch ruler? If I want to figure that out, what I can do is I can plug in 18 for x, because remember, x is our inches, so I can just plug in 18 for x here. Now, y equals 2.54 times 18, and if you put that in the calculator or do it longhand, you're going to get 45.72 centimeters. Next, try this one on your own. A florist sells a dozen roses. A dozen is 12 for $35.40. She sells individual roses for the same unit cost. So, unit rate. Write an equation to represent the relationship between the number of roses, x, that's what it lists first, and the total cost of the roses, y. So cost, so remember, it's always y over x. So our cost is going on top. So our cost is $35.40. And then our x goes on the bottom, which is the number of roses, which is 12, because a dozen is 12. So $35.40 divided by 12 is 2.95, which means our equation, y equals kx. Okay, this is k. Y equals 2.95x. And if we need to figure out how much 18 roses costs, we're just going to plug in 18 for x. And we're going to get y equals 2.95 times 18 is $53.10. Example 3. Determine whether y equals kx describes a situation. Okay, so we're going to determine if we have a proportional relationship here, which we've done a little bit already. Okay, can you represent the total cost y for admission and x rides at the amusement park using an equation in the form y equals kx? Explain. Make a table that shows the total cost. Then we're going to compare the ratios to determine whether the relationship is proportional. So if you look at this, it says, welcome to Fun Fair. Admission is $20. So to get into Fun Fair, you have to pay $20. And then each ride you go on is $5. So you automatically have to pay $20. And then it's going to be $5 for every ride you do after that. So I'm going to make a table, rides and cost. If I go on one ride, it costs $20 to get in. Each ride is $5. So if I go on one ride, my total cost is going to be $25 because I paid $20 to get in plus the $5 to go on that one ride. If I go on two rides, it's $20 to get in, two rides, $5 per ride, so that's 20 plus 10, which is $30. And if I go on three rides, it's going to cost $35. Okay, now we're going to divide out these ratios and see if it's a proportional relationship. So 25 over 1, 25 divided by 1 is $25. 30 divided by 2 is $15. 35 divided by 3 is $11.67. So if you look at these numbers, they are not the same. So the relationship is not proportional. So it cannot be represented by y equals kx. Okay, next, try it. Balloon A is released 5 feet above the ground. Balloon B is released at ground level. Both balloons rise at a constant rate. Which situation can you represent using an equation in the form y equals kx? What we're going to do is we're first going to look at balloon A. We're going to divide all of these things out and see if we get the same ratio. So 9 divided by 1 is 9. 13 divided by 2 is 6.5. And 17 divided by 3 is 5.7. So that doesn't work. They're not the same numbers. So let's try this one. Hopefully this one works. 4 divided by 1 equals 4. 8 divided by 2 equals 4. 12 divided by 3 equals 4. Oh, great. Okay, so we have the same ratio here. So which situation can you represent using an equation of the form y equals kx? The height of balloon B can be represented by y equals 4x because the ratios are equivalent. Okay. Now I want you to do the do you know how questions. I'm actually going to do these ones with you today, and then I want you to do these ones on your own. Okay, so for these questions, it says determine whether each equation represents a proportional relationship. If it does, identify the constant of proportionality. So remember, equations are in the form y equals kx. When we have a proportional relationship, it's y equals kx. So if you have like plus something or minus something on the side here, it's not going to be proportional. So if we look at this, this is y equals kx, but then there's a minus 2 here. And since there's a minus 2 here, that means that our initial value, the value we're starting with, is negative 2, and it's not 0. It needs to be 0 for it to be proportional. So we're going to say no, okay? It's not a proportional relationship. This is in the form y equals kx. We don't have any plus or minus something, so this one's yes. This one, what do you think? It is no, okay, because we have a plus 1 here. Do these two on your own. I'll post the answers in Google Classroom, and then you are going to work on your practice and problem solving, just that first page, and submit that to me. Have a good day. Happy St. Patrick's Day.